Okay, today we're going to do the derivatives of trigonometric functions. Now, let us begin by considering a function f of x equals sine x. And we'll have x in radians, and we're going to think about a very small part of sine x, just right at the beginning of the sine x curve. So we've got some value of x here, and that is f of x. And we're going to imagine some point x plus some small increment dx, and then the value of that will be f of x plus dx. And this is f of x equals sine x. So if we were to do dy by dx of the function as the limit dx tends towards 0, we'd have this function f of x plus dx minus f of x divided by x plus dx minus x, because that's just the value for the gradient. So this is, if you remember, our general rule for the gradient m is y2 minus y1 over x2 minus x1. So that is our y2, our y1, x2, x1, and that, because the derivative is the same as the gradient, that's where this comes from. So as the limit of dx tends towards 0, we'll put, instead of f of x, we'll write sine of x plus dx minus sine x all over, so x plus dx minus x will just give us dx. Now we can expand sine x plus dx using the compound angle theorem. So we'll have the limit of dx tend to 1, and that will give us sine x cosine dx plus cosine x sine dx minus sine x all over dx. Now as dx tends towards 0, cosine of dx will tend towards 1, and sine dx will tend towards dx. So what we're going to get here is sine, the cosine is going to turn to 1, sine x is going to be, is just a sine x, and that minus sine x, they'll cancel, and then we'll get a cosine, and this sine dx will change dx and cancel this dx, so we're just going to end up with cosine x. So what this tells us is the derivative of sine x equals cosine x. Now we can do the derivative of cosine x. Now we could do exactly the same argument, and what you would end up having is minus sine x. Oops. Now for the tangent, that's going to be a wee bit different. So we've got d by dx equals d by dx. Oh, sorry, that means nothing. D by dx of tan x. Now instead of writing tan x, we're going to put in sine over cosine. And the reason we do that is we can now use the quotient rule. So we'll end up with cosine x times the derivative of sine x minus sine x, the derivative of cosine x, all over cosine squared x. Let's put the values of the derivatives in. This will give us cosine x, and that's cosine x, so it's cosine x squared, minus, and minus is going to end up, that's going to become minus sine x, so that's going to become plus sine x, and that's sine x there, so sine x squared, all over cosine squared x. Cosine squared plus sine squared is 1. That's going to be over cosine squared x. Now we know this trigonomic identity is equal to sec squared x. So the derivative of tan x equals sec squared x. So let's now do some examples to put this into practice. So if y equals 2 sine x, dy by dx is going to be, the 2 is going to just be there. Sine x is going to become cosine x. If we had y equal x cosine x, so this is going to use the product rule, so u is x, v is cosine x, du by dx equals 1, dv by dx equals minus sine x, and therefore dy by dx is equal to u dv by dx plus v du by dx, and u is x, dv by dx is going to be minus sine x plus v, which is cosine x times 1. So that will just give us minus x sine x plus cosine x. Let's do another one where y is equal to tan x over x squared. So this time we're going to use the quotient rule. So u is tan x, so du by dx is going to be sec squared x, v is x squared, dv by dx will be 2x, and then dy by dx is going to be v du by dx minus u dv by dx over v squared, and so that's x squared, and du by dx is sec squared x minus u, which is tan x, and that's multiplied by dv by dx, which is, put here, 2x over x to the power 4, and now we can take x out, and then that will cancel, so we'll take an x out here and x out there, so it's going to be x sec squared x plus, well not plus, minus 2 tan x all over x cubed, because that x plus an x is cancelled with the x that we've taken out here. And finally, Let's do another one. So if we've got y equal to 3 plus 2 sine x, and all that is raised to the power 5, we're going to have the chain rule this time. So u is 3 plus 2 sine x, du by dx is going to just be 2 cosine x, and then dy by dx, so we take the derivative of the 5, comes down here, and that's going to be 3 plus 2 sine x raised to the power 4 multiplied by 2 cosine x. So that'll give us 5 times 2 is 10 cosine x, 3 plus 2 sine x to the power 4. Now, what if we have a trigonometric function of the form sine ax plus b, or cosine ax plus b, or sine, or not sine, tan ax plus b. So let us deal with this one first, and we'll just use the chain rule to work out what this would be. So we'd have y is sine u, where u is equal to ax plus b, and dy by du is going to be cosine u, and du by dx is equal to a. Therefore dy by dx will be equal to our dy by du times du by dx. That's not shown up properly. So that's cosine u, but we're going to substitute back in with what our u is, ax plus b times du by dx, which is a, so we'll put the a here actually just for neatness. So we get this. So therefore, we can do the same with all three of these functions to get the general rule. D by dx of sine ax plus b is going to be a cosine ax plus b. D by dx of cosine ax plus b is going to be minus a sine ax plus b, and finally d by dx of tan ax plus b will be equal to a sec squared ax plus b. Now it's important that in calculus, so this is important to note, in calculus all angles are measured in radians unless the question states otherwise. So sometimes you might have a question where it is in degrees, but the question will explicitly say that. If it doesn't say it, always assume that you're dealing in radians. Okay, so let's do some examples of these more general trig functions. So y, and this is one, y equals sine 3x. So the derivative is going to be, this is what our a would be, so that's going to be our 3 times 2 is 6 sine, oh not sine, cosine 3x. Y equals 4x tan 2x. So this one here, we will be using our product rule. So we've got u equal to 4x, v equals tan 2x, du by dx equals 4, dv by dx equals 2 sec squared 2x, and dy by du by dx is therefore going to be u dv by dx plus v du by dx. So u was 4x, and now times that by 2 sec squared 2x plus v, which was tan 2x, multiplied by du by dx, which was just 4, so just shove the 4 there. So that will be 8x sec squared 2x plus 4 tan 2x. Let's do one that will involve the quotient rule. So y equals cosine 2x minus pi over 4 over x squared. So we've got u equals cosine 2x minus pi over 4. So du by dx equals minus 2 sine 2x minus pi over 4. V is x squared, and dv by dx equals 2x. So dy by dx will be v du by dx minus u dv by dx over v squared. So that will be, our v was x squared, and du by dx is minus 2 sine 2x minus pi over 4, and then minus u, which is cosine 2x minus pi over 4, multiplied by dv by dx, which is 2x, all over v squared, which was 4x to the power 4. Now we can take x's out, and that will give us minus 2. This x is going to be taken out, so it's just going to be 1x there now, sine 2x minus pi over 4, minus, and this x has been taken out, so it's just 2 cosine 2x minus pi over 4, all over x cubed, because we've cancelled that out. Let's do one more. This time we're going to use the chain rule. So we've got y equals 3 minus 2 cosine 5x to the power 4. And so we'll have u equals to 3 minus 2 cosine 5x. So du by dx is going to just be, so cosine will become minus sign, but that'll cancel with that. So, and we've got the 5 coming out here, so that'll be 10 sine 5x. And our dy by du, that's going to be u, will be 4u to the power 3. So dy by dx is going to be 3 minus 2 cosine 5x to the power 4 multiplied by 10 sine 5x. So 10 times 4 is 40 sine 5x, 3 minus 2 cosine 5x to the power 4. Oh, to power 3, sorry. And that's obviously to the power 3 too. because of that. So I hope that helps.